Now that we've talked about inductive reasoning, which is based on observations, let's talk about deductive reasoning. So what is deductive reasoning? It's the process of reasoning logically given statements to lead to a conclusion. So again, we need to be given specific information, and this time it's not an observation of a pattern, but we're given statements. And we're going to come up with a conclusion or a conjecture based on those statements. So there are two laws that we're going to go over, the first being the law of detachment. So the law of detachment is basically when you're given a conditional and then one other piece of information. So I know it says with your partner, but we're not doing this in class, so don't worry about the partner part. I want you to look at A and B, and you tell me which of these two situations can you actually create a conjecture or a conclusion from. So take a moment and read that and tell me what you think. Okay, so if we take a look at A, if the car battery is dead, then the car won't start. The car battery is dead. All right, so if the car battery is dead, then what do I know? The car won't start. So if we take a look at B, what about this one now? If the car battery is dead, then the car won't start. So the same conditional is there. And now I'm told the car won't start. So what can I conclude? Well, you might be tempted to say, okay, well, the car battery is dead. But think about it with some little logic. Is the car battery, is the only reason the car won't start the car battery being dead? No, right? Maybe you're out of gas. Maybe you don't have, your starter's broken or something. I'm not a car person, so I'm not going to go with any more examples, but it's not the only reason, right? So we can't make a conjecture here. All right, so now I want you to actually go back and look at what is the big difference between A and B. Well, if you look, our conditional statements are the same, right? We have the same hypothesis and the same conclusion, right? The car won't start is our conclusion. The car battery is dead is our hypothesis. Now what changed was the statement. So you see the additional information we're given in A is the hypothesis again, versus the additional information we got in B was the conclusion. So you can see if we are given the hypothesis, we can make a conjecture. But if we are not given the hypothesis, we can't make a conjecture. And that is the law of detachment. So once again, the law of detachment is when you're given information, specifically you're given a conditional if P, then Q, and you need to be given one additional piece of information, which is that P happens, then we can conclude as our conjecture that Q will also happen. Okay? So again, that's kind of like back to that A up there, right? We're given if a car battery is dead, then the car won't start. And then we're told, hey, this car battery is dead, or, you know, Miss Huang's car battery is dead. What's going to happen? Well, her car won't start, right? But we can't conclude anything if we're given Q instead of P. So go ahead and try you try A and B, and I want you to tell me if the conjecture is valid, and think why or why not. All right, so what did you notice about A? Well, A, if the road is icy, then the driving conditions are hazardous. But we're told the driving conditions are hazardous, which again is the conclusion. So if we're given the conclusion, we cannot create a conjecture. So the conjecture is not valid. And again, why? Because we're given the conclusion and not the hypothesis as the additional piece of information, right? So with B, the area of the square is 9 inches. Oh, and that should be square inches, so that's a typo there. Sorry about that. Is 9 inches. Well, that should be valid. And why is that? Well, that's because we were given the conditional, right? If P, then Q. And then we were told that P happened, right? The occurrence is P, which is what we want for law of detachment. So it's valid by the law of detachment. Okay? come back to class with questions if you have any questions on that. We'll be practicing in class. The second part of deductive reasoning is the law of syllogism. So once again, I know we don't have partners today, but using your own brain, figure out if you can draw a conjecture or a conclusion from the statements. And only one of them should work, so think about it. Well, hopefully you saw that A leads to no conjecture, but B does. And if you look at it with A, if a number ends in 6, then it is divisible by 2. If a number ends in 4, then it is divisible by 2. These are two completely unrelated statements because there's no link between the two sentences, the two conditionals. Rather, if you look at B, if a number ends in 0, then it's divisible by 10. If a number is divisible by 10, then it's divisible by 5. And you'll see that linking piece of information. It is divisible by 10, and you know what? Let me stay color-coded before. So, it is divisible by 10 was the conclusion of the first conditional, and then you'll see it repeats as the hypothesis of the second conditional. And that's a linking phrase that now creates a related statement. So then here, we'd be able to say, well, hey, if a number ends in 0, then it has to be divisible by 5 too. Alright, so that's kind of like what I like to say, cutting out the middleman. So you have that repeated phrase that links your two pieces of information, which then creates a brand new statement, versus, again, A, where we can't write a conjecture, right? Because they are completely unrelated. They don't have anything linking together. So this is what we call the law of syllogism. It's when you have two conditional statements, and no matter what the order they come in, you see one conclusion repeats as the hypothesis of the other statement. Then we can create a brand new conditional statement putting the hypothesis and the conclusion, which don't repeat, together. So we are given this information. We are given two conditionals, right? If P, then Q. And then you're going to see that Q repeat, and it'll be if Q, then R. Okay? If you're given that information, then we can go ahead and cut out those two repeated Q's and conclude that if P happens, then R will also happen. So it'll become if P, then R. And again, the order could be flipped. You might be given if Q, then R, and then if P, then Q. But as long as you can cut out those two repeating Q portions, it'll be fine. So if you take a look at the U-try problem, go ahead and try those out, A and B. And again, we'll definitely be practicing this in class so you can start recognizing the patterns. So even though it's deductive reasoning, we're using statements, we're still using pattern recognition, our inductive reasoning here, to determine if we can make a conclusion. So try that out, A and B. All right, so which one of these were valid? Were they both valid? Were they both invalid? What did you figure out? Well, A should be a valid conclusion, and why? Because it follows the law of syllogism. We've got P, Q, Q, and then R. So it follows that lovely pattern, right? So the quadrilateral pieces repeat, so we don't need, we can cut those out and then combine the remains to make a brand new statement, right? So I can combine, if a figure is a kite, then it is a polygon. All right, versus B, what did we find out about B? Well, you should be able to create a conjecture here, but the conjecture is actually incorrect. So let's take a look at what happened here. So what I like to do is I actually like to find the repeated portions first. So you'll see even, repeats. So then I know that's the Q part. And look, they're in this zone where one's a conclusion, one's a hypothesis. So that tells me I could actually create a conjecture out of this. So there's my R, and there's my P. So if I were to create a conjecture, it should be, if a number is divisible by 2, then it is an integer. So this conjecture is not valid because it's not in the right order. This goes if R, then P, which is not what we want. Okay? So that is it for deductive reasoning. Again, come to class with questions. We'll be practicing this in class.